In this lecture, we're going to work on an array of characters and show how special they are. You can declare an array of characters just like any other array. So here we have an array called message. It stores elements of type character. The size is 5, and we initialize it with a bunch of characters. If we want to print it out, we can loop like we loop through any other array. In this case, we're going to be using a range-based for loop. We say for auto_c, we pass the message, and then we're going to be printing each character in the message. And if we do this, we're going to see hello printed out on the console. We can also modify elements in our array. For example, we can say message1 and change the E here to an A. And if we print out, we should see hello printed out on the console. Nothing really special so far. The cool thing you can do with character arrays is that you can print them to the console directly without even doing the loop. You can do something like this. You can do stdcout, you say whatever you want to do in quotes here, and you're going to print the message. But sometimes this won't do what you expect because only proper C strings can be printed on the console. And what makes up a proper C string? A proper C string has this thing you see on the end here. This \0 is called a null termination string. And it is what is going to tell C++ that we have hit the end of the string and we are going to stop printing it if we are printing with things like stdcout. So this is really important to be in your strings. If it's not there, it may work, but sometimes it's also going to print some garbage characters after this. Because what tells stdcout that we have reached the end of the string is this \0 here. If it's not there, it's going to keep printing until it sees one, and then you're going to probably have some garbage characters added to your string, and that's not what you want. So to have your strings printed out correctly, be sure to have in this null termination character here. And if we print it out, we're going to get it, and we're going to see the size printed out properly if we do things like this. But it is possible to get this autofilled for us. If you look here, we have a character array called message2. Inside we have said that we need 6 elements, and we say hello. So we have 1, 2, 3, 4, 5 elements. And the elements we don't initialize properly is going to be initialized with a 0 version of a character. And that happens to be the null terminator of the null termination character. So this is going to print correctly, and we're going to have the \n appended to this for us by the compiler. But be sure you understand the difference between this and this. Here we have specified the size to be a 5, and we are putting in 5 elements, so we have no null character appended to this string. But here we have said that we can put in 6 elements, and we have only put 5, and the compiler is going to autofill then the null terminating character. These two things are different, and make sure you understand the difference. Okay, so now take a look at what we have here. We have a string, we didn't specify the size, and we just initialize it with hello. Someone might think, this is also going to autofill, but it's not, because the compiler is going to deduce the size of this array using what you initialize it with. And you didn't put in a null character, so it's not going to be accounted for. You're only going to have this here. And if you print this out, you may get garbage characters appended to your string here. So be careful. But it is possible to do literal C strings and only say hello like this in quotes, and you're going to get the null terminating character appended to your string here. So if we print this, this is going to print nicely. And this is the recommended way to initialize your character arrays. If you want to put in string data like this, you have to use double quotes. And the cool thing about this is that you can even put in spaces between words like this. It is going to work. This really looks like how you would like to type text and store that in your character arrays. And we're going to be using this a lot in the course. Again, I want to bring to your attention that character arrays are special in that you can directly print them on the console like we are doing here. You see, this is a character array, and we are saying stdcout message4. You can't do this with other arrays. And this is really all I had to share about character arrays. So what we're going to do next is head to Visual Studio Code and play with us. Okay, here we are in our working directory. The current project is arrays of characters. We're going to grab our template project and we're going to copy the files, bring them in here, and we are going to open our folder. We're going to open the main CPP file and we're going to get rid of what we don't need here. Let's put in some starter code so that we can start playing with this without typing this too much. So we're going to declare an array of characters. It's going to be called message. The size is going to be 5 and we're going to fill it with characters like this. So if we do this, we might want to print it like we print any other array. We're going to use loops. And in this case, we chose to use a range-based for loop. So we take auto C for character in message, and we're going to print out each character. Notice that we're not adding stdendl here because we want the characters printed close to each other so that we can read this easily. And after this, we will need to go to the next line so that the next thing we print doesn't disturb us. So we're going to say stdcout stdendl. And if we do this, we're going to see hello printed out on the console, but we had to do too much work to print something simple like hello. But let's do this. We are learning. So we're going to bring up our terminal and we're going to build with GCC. Let's do that. The build is going to go through and we're going to clear and run Rooster. You're going to see that it's going to say message is hello, and this is what we expect. And this is really how you would declare an array of characters and initialize it with whatever it is you want to initialize it with. But you notice that it's really not convenient to put data in here. If you want to store a message, for example, for someone, you don't want to do this thing you see here. It's really ugly, it's inconvenient, and nobody would definitely use your program if you required your users to type things like this. So we need to change this, and we will. But before we get there, let's also see that we can change characters in our array. So if you look here, this E here is at index 2. So what we can say is say message, and we're going to target the element at index 2. Oh, it's index 1. Let's use that. So this is index 0, the H, and the E is at index 1. Let's make sure we get this straight. And we're going to store in an A in quotes. Remember, characters are surrounded by single quotes like this. Once we do this and we try to print the array out again using our technique here, we're going to copy the code and we're going to paste it down here just to do this simply. And if we do this, we're going to see the message printed out here to be hello. And the second message is going to be hello with an A because we changed the second element to an A. It's no longer an E. So that's what we expect. We're going to run the task to build with GCC. And we're going to bring this up and clear. And we're going to run Rooster. You see that we have message hello and message hello. And we are able to print things successfully. This is really cool, but we are doing too much work really to print something on the console, and there should be an easier way to do this, and there is. So what we're going to do is comment this out because we don't want noise output in the console when we try to do something else. So what we're going to do is comment out all we've done so far. We're going to leave in our message here. And we're going to try and print it directly on the console. So we can say stdcout and say message. And we're going to print out the message. And take a moment and look at this and try to compile this. It is going to go through, it is going to compile because C++ supports printing character arrays like this. But in most times, this is not going to do what you expect. Let's try and run this and see what we get. We're going to run Rooster, and you see that we're lucky to get something that really isn't what we expect. It's printing hello, and you see that we have a bunch of other things. And the reason is what we have discussed in these slides. For character arrays like this to be printed out properly on the console, they need to be null terminated. In other words, they need to have the null character, which is a \0, appended to the string for stdcout to know that it has reached the end of the string. So this is what makes your character strings legal. Now you see that we are getting a compiler error because we have overflown the size of the array. I think that's the message, too many initializer values, and this is exactly what we have done. Now we can try and change this guy to a 6 to say that we have 6 elements in here. This squiggly line should go away. And if we try to build and run, I'm going to build with GCC. Let's bring this up a little bit. And we're going to clear and run Rooster now. And you see that now we have hello printed out correctly. If we turn this back to 5 elements and take out the null terminator, we're going to try and build again. And we're going to clear and run Rooster. You're going to see that we get the garbage back. So for your strings to be printed out correctly, they need to be null terminated. That's why it is not safe to print something like this when your character array is not null terminated. I really want you to understand this. So in C++, we have a proper name for these strings that are null terminated. A null terminated string is called a C string because these things come from the C programming language. Okay, and we're going to see a few ways we can set up C strings now. And the first one is to say car. We can call this message1, and it's going to be an array of characters. And we're going to initialize this with hello. Let's copy this because I don't want to type all these things here. So let's copy this and initialize this properly. Notice that we didn't specify the size, so the compiler is going to get the size from however many elements we put in here, and we're going to put in our null terminator here, and if we print this, this is going to work. And we are going to comment this out, and we're going to say that this will give you garbage. Okay, if we come down here, we're going to see that we have a car array. It is called message1, and we have initialized it with data. We have hello, and we have a null terminator here, and the compiler is going to reduce the size. So this is going to be a proper C string, and we will print it correctly. Let's try and build this. The build is going to go through. If we clear and run Rooster, we're going to get our message here, and this is one way we can set up a proper C string. The second way is to actually not put in the null terminator, but let the compiler add that in for you. And the way we can do that, we can say car message2, and we're going to say this array is of size 6. Let's say that. We're going to put in a 6 and fix how we end things here. We're going to put in a quote and end this with a semicolon. Now what is going to happen is the compiler is going to see that this array is of size 6, but we are putting in 5 elements. So the remaining slots are going to be autofilled, and it is going to be using null terminators to autofill this then. If we try to print the size here, we're going to get a 6 because the null terminator is added in by the compiler. Let's try and print the sizes here actually so that you can see these things. So we're going to say size, and we're going to say that size of message1, and we're going to put in a new line character, and this should be what we expect. So what we're going to do, we're going to copy this and put that down here because we're going to be doing the same thing for message2. So we're going to say message2, let's select this, and say size of message2 and do size of message2. So what we're going to see is message1 and message2 printing out, and we expect to see a size of 6 because both of these guys have 6 elements inside. So we're going to run the task to build with GCC and bring this up, clear, Rooster, and this is exactly what we expect. Message1 is hello, the size is 6. Message2 is hello, and the size is 6. And these are a few ways you can declare your character arrays and initialize them with proper data that is going to print correctly with stdcout. Make sure you don't do something like we did here by printing message here because it is not null terminated. This is going to give you a lot of problems. Again, I want to make it really clear that message3 here is not a proper C string. because the compiler is going to deduce however many elements we have in here, and this thing is going to be of size 5. And we're not going to have a null terminator, and if we print it out, we're going to get some garbage. So let's try and copy this so that we are consistent with what we've done above here. And if we compile with GCC, we are going to compile successfully, but we may get weird things if we print out message 3 like we do here. And you're going to see that the size is 5 because we only have 5 elements in here. So let's clear and run Rooster, and you're going to see that we have hello for message 1, we have hello for message 2, but for message 3 we have things we don't expect, because it's going to keep printing and it's going to go overbound, and it's going to stop when it hits the first null terminating character like what we have in here. Okay, so this is not safe, don't do it. Make sure your strings are null terminated if you intend to print them with stdcout like this. Okay, so working with character arrays like this to print messages and do all kinds of crazy things is nice, but it really isn't convenient. As I said before, you wouldn't expect your users to type characters like this by surrounding them with single quotes. This is really ugly, and it is painful to do if you want to do some productive work. So C++ allows you to use what we call string literals, and we're going to see an example of that down below. We're going to say string literals, and what we can do is car message 4. It's going to be an array as usual, and we can initialize it with a string that is surrounded by double quotes. And what this is going to tell C++ is, take these things, break it into characters, and store this in this array here, and make sure you properly null terminate this string here. So if we print the size of message 4, we're not going to get 5, we're going to get 6, because C++ is going to see these double quotes and know that we intend for these things to be properly null terminated, and it's going to add a null terminator. So let's try and print this out so that we really are sure. And we're going to build this with GCC as we always do. The build is going to go through. Let's go up and clear, and we're going to run Rooster, and you see that message 4 is hello, and the size is indeed a 6. So this is one way we have to do things, and we can even put spaces and do all kinds of crazy things, and it's really cool. And if we try to build this, we're going to get the proper message printed out. You see the build is good. If we clear and run Rooster, we're going to see hello world, how are you doing? And this is really cool. So from now on, if we need to store a string in our program, this is how we're going to do it, because this is much more civilized, and it is how you would really like to type characters in your program. I have said that character arrays are really special because you can directly print them out with stdcout like this. I want to prove this, so we're going to try and declare another array. So we're going to call this numbers, and we're going to make this an array, and we're going to initialize with 1, 2, 3, 4, 5. This is going to do, and we're going to put our closing semicolon, and we're going to try and print this out. We're going to say stdcout and say numbers. Let's see what we get. Let's try and compile this and see what we get. It is not actually going to give us a compiler error, but it's not going to print what we expect. And let's put a message here so that we know that it is this thing we are seeing here. So we're going to say numbers, and we're going to put a colon here. And we're going to build this with GCC. And we're going to clear. And if we run Rooster, look out for the output that says numbers here. So let's run Rooster. It's not a 1, 2, 3, 4, 5. It's something we don't really know. And we will get to understand what is happening here in the next chapter. For now, know that you can't directly print arrays other than those of characters. If you try to do that, you're going to get weird numbers printed out. And we're going to understand why this is in the next chapter. So let's say that here. Okay, this is really all we set out to do in this lecture. I hope you found it interesting. Character arrays have a few things you need to be careful about, and we try to cover those in this lecture. We are going to stop here in this lecture. In the next one, we're going to try and look at array bounds. Go ahead and finish up here and meet me there.